In this video, I want to talk about evaluating sequences in their recursive forms. So in general, a recursive formula essentially relates a term in a sequence to its previous terms. And before we look at more complicated examples, let's just review two different types that we've already seen before. For instance, this first one, this is the recursive formula for arithmetic sequences. And the one below it is the recursive formula for a geometric sequence. So the general idea is that for both of these, we're given the first term and then we're given the pattern. Or essentially, we're given a way to find a term in the sequence based on a previous term. So let's look at this arithmetic sequence first, where we're told the first term is 10, and then we're told that to find the nth term, you want to take the term before that, the n minus 1 term, and subtract 7.5. So specifically, this number here, this subtracting 7.5, this is what we call the common difference. To go from one term to the next, we will subtract 7.5. So you could figure it out from that way, but if, let's say, you didn't have familiarity with this, then you would start by figuring out the second term, since we already know the first. And the second term, we're just setting n equal to 2 here. And in our formula, g of 2 would be equal to g of 2 minus 1, or g of 1 minus 7.5. And g of 1 is just 10. So we take 10, we subtract 7.5, and we get 2.5. So the second term in the sequence here is 2.5. And to find the third term, we would just repeat this pattern. So now we're setting n equal to 3. And so we have g of 3 is equal to g of 3 minus 1. So g of 2 minus that 7.5. And we know g of 2, we just found that. That's 2.5. And we're going to take 7.5 from that, and so that gives us minus 5. So minus 5 is the next term in the sequence, and you could repeat this. You can go to g of 4 next, g of 5, and so on, or just recognize that going from one term to the next, we're just subtracting that common difference of 7.5. So if we continued this, the next one would be minus 12.5. Then we do it again. We get to minus 20. And it goes on and on forever. This is infinitely long. So g of 3 here is just this minus 5. So we can put that into our box. And the geometric sequence is going to work similarly. We're given the first term, and to find the second term, so we'll just set n equals 2 here in our formula. So f of 2 would be f of 2 minus 1, which is f of 1. And then with geometric sequences, we have what's called the common ratio, the number we multiply by to go from one term to the next. So we're multiplying our first term by minus 1/5, so that's 25 multiplied by minus 1/5. And that would be negative 5. So the sequence, it starts at 25, then goes to minus 5. And we'll continue this. Now we'll set n equal to 3. So we have f of 3 is equal to f of 3 minus 1, which is just the second term, multiplied by minus 1/5. And that second term was just negative 5. So we have minus 5 multiplied by minus 1/5. The negatives cancel. 5 divided by 5 is just 1. So we get 1 here. And you can see the pattern. Going from one term to the next, we are just multiplying by minus 1/5, or 1/5. So the next one would be 1 times minus 1/5, which is just minus 1/5. The term after that would be positive 1/25, and this goes on forever as well. And we just need to find the third term, which was 1. So we'd put 1 into our box here. So these two examples are ones we've seen before, specifically for these arithmetic or geometric sequences. But in the next problems, we're going to look at different types of recursive formulas And generally, they work the same way. It just might be a more complicated pattern. But remember, the main idea of these recursive formulas is that to find some term in the sequence, the formula relates the nth term to previous terms in that sequence.